you guys, so lesson 9 is permutation and combination. So make sure you have out your notebook or whatever you're taking notes in. And we will go ahead and get started. So the first thing we're going to talk about is the fundamental counting principle, which is something that you guys probably learned in Algebra 1, if not pre-algebra. So if I had 3 pairs of shoes and 2 pairs of pants and 5 shirts, how many outfits? So I think of this as I do like 3 events. There's the shoes, pants, shirts. So how many different potential outcomes for shoes do I have is 3. How many different potential outcomes for pants do I have is 2. How many different potential outcomes for shirts do I have is 5. So that means 30 outfits. So this is the first idea that we're going to look at. This says each license plate in a certain state has 5 characteristics with repeating allowed. Here's what can go in each spot. So I'm going to think of this. I have 5 events, spot 1, spot 2, spot 3, spot 4, spot 5. This is the 5 spots that make up a license plate. I want you to think, pause the screen, and put how many options you think go in each spot. So how many options do I have for the first spot, second spot, third spot, fourth spot, and fifth spot? Go ahead and pause your screen and fill those in. Okay, we should have gotten this, and we were allowed to repeat numbers, so it's going to be 26 and 26. So what this comes out being is there's this many license plate options for the state. Go ahead and take a second and read this problem to yourself. I'm not going to read it to you. You're taking a second to read this problem. Okay, so this is telling us that we have a code. We have letter times a letter times a letter, and then 1 digit, and then a letter for this coupon code. PQR cannot be used, so there's 23 letters in every spot, 10 digits, another 23 letters. So this would get us this many different coupon choices. So we're going to set up, this is with repeat. We're going to set up one without repeat. So what will look different about this, if I cannot repeat letters, once I use 23 letters, I've used 1, so now I only have 22 options. Then I only have 21 options, and by the last spot, I only have 20 options. So that would be what that looks like if we could not repeat. Okay, we're going to talk about this idea of factorials. So when we do 4, 3, 2, 1, we took 4 and multiplied it all the way down to 1. And we got 24. Another way we could write that is 4 factorial. So that means to take every number after 4 and multiply it until you get to 1. So for example here, if I see 3 factorial, that's every number below 3 down to 1. 2 factorial is every number below 2 down to 1. So this exclamation point is kind of like a is what the factorial means. So this is the exclamation point, that's a factorial. And it tells us to do like an operation. So it's not a variable we're not screaming for. It's telling us to do an operation. So back to this 3 factorial over 2 factorial, it would then simplify. We could cancel out the 2 and the 3, sorry, and we just have a 3. Now, if I gave you something like 2 factorial over 2 factorial, anything divided by itself is 1, but I'm going to show this to us. It'd just be 2 over 2 or 1. So keep that in mind. A factorial over itself is still 1. So the last thing we're going to talk about with these is when you see one like example 10, we know our bottom is 7 factorial. So it is easiest to start at 9, 8, or 10, 9, 8, and then stop at 7 factorial. Because a factorial divided by itself becomes 1. So those divide to 1. So this simplifies to 10 times 9 times 8. So if you saw something like 100 factorial over 99 factorial, what would be easiest is to keep the bottom at 99 and then do 100 times 99 factorial instead of writing all of those out on the top and the bottom. Those would cancel out and become 100. So this is our basic use of factorials. Okay, I want you guys to take a second to pause your screen to simplify this, write this out. So you're pausing your screen, simplifying this, and writing this out. Don't need to solve it yet, just write out what you can with it. I'm going to go ahead and do it myself. Go ahead and pause your screen. I'm going to do 5, 4, 3, 2, 1. And then, oh, what is happening, friends? Okay, we're back. So this 5, 4, 3, 2, 1 cancel out. And this 2, 1 cancel out. So really, in the numerator, all I have is 5, 4, 3, 7, 6. Gets us 60 over 42 or 10 over 7. Okay, so go ahead and read this problem. Should we take a second to read this problem? Okay, so it wants to know we have a pencil, eraser, desk, and chair. And it wants to know how many ways we can order those if order is taken into consideration. So let's just think fundamental counting principle. I have 4, 3, 2, 1. Or I have 3 spots, sorry. I want 3 objects. There's 4 spots for the first. There's 4 objects for the first spot, 3 for the second spot, and then 2. That gets me 20 more options, or 24 options. Also, if I took the time to write all these out, I would see that I have 24 options. When it says order matters, that's saying PED is different than like DEP. So let's look at B, where choice is not into consideration. So what we're saying there is PED is the same as DEP, EDP. So any 3 ways you can combine objects is only going to count as 1. So order does not help us. It doesn't matter if it's DEP. It doesn't matter if it's DEP or PED. That would only count as 1 choice. So let's go through and look at this. I'm going to go through and highlight. I'm going to pause it and I'm going to highlight all of what it represents, and you guys will see what I'm talking about in a second. So PED, this combination, this would only count as 1 option. This would be this second combination. This would be the 3rd potential, and this would be the 4th potential. But any PDC combination is only going to count as 1 option. So there's 4 ways. If we say order does not matter and all these count as 1. Okay, so another way to kind of talk about what we just were doing is permutation versus combination. So permutation order does not matter, or permutation order does matter, combination order does not matter. So you're going to want to take these notes. So if order does not matter, we call it a combination. If order does matter, we call it a permutation. And then we use these formulas. So this is our factorial. So remember, our exclamation point is a factorial. So I think of n as how many options and r as how many we want. So we will practice these. You're going to want to write down these formulas. So we would say this as like n choose r. So I'm going to have 5 things, but I'm only going to choose 3 of them. Okay, let's try the earlier problem that we just did about the pencil, eraser, desk, and chair. Let's try the same problem using these formulas. So if I have A, order does matter. The order does matter, so I'm going to use this equation. And I have 4 options, but I only want 3. Four factorial is 4 times 3 times 2 times 1. 4 minus 3 factorial is 1 factorial, or just 1. So I'll still get 24 over 4, or 24 options. Let's think about if order is not taken into consideration. I'm going to use this. So I use the C, or combination. I have 4. I'm still choosing 3. So I'm going to do 4, 3, 2, 1 over 1 factorial, which is just 1 over times 4, 3, 2, 1. This ends up being 4 factorial, or 4 over 1 factorial, or just 4 options. This is exactly what we got when we just did this a couple slides ago. Okay, I want you guys to try this first one on your own, the 10 choose 3. This is another way that you could say, see it like this. You'll see it written different ways at different points. So let's try our 10 choose 3 combination. Go ahead and pause. I'm going to try that, and you guys will check and see if you got what I got. Okay, hopefully you guys at least got to this point where we have a 10 times 9 times 8 over 3 times 2 times 1, which becomes 6 over 910, which becomes 120. Go ahead and try the second one on your own. Okay, first off, this should have been an 8, 10 divided by 6, which is 120. I'm sorry. That's my mistake. Okay, and then these would cancel out. And this simplifies to 6,720. So that's our basics for permutation combination. Okay, I want you guys to take a second to read these on your own. I want you to think, what is my N and what is my R? How many do I have and how many am I choosing? So I have 16 objects. I'm choosing 4 or 5. This first one is choice does not matter, or order does not matter. It's not going well, friends. Order does not matter is going to be this. Order does matter is going to be this. I want you guys to take a second, pause the screen, try to write the equation that you're going to use for A, and try to write the equation you're going to use for B. So pause the screen, do that. So we should have gotten 16 choose 5, which is 16 factorial over 16 minus 5 factorial times 5 factorial. And we should have gotten 16p5. Okay. So we can go ahead, pause your screen, start simplifying this. I'm going to simplify them. Okay, and hopefully we at least got to this point on them. So our 9 factorial would cancel out of both of them. For our top one, if we put this in a calculator or did it by longhand, we would get 4,368 options. For the bottom one, we would get 524,160 options. Okay, this is the last slide. I'm going to give you guys a second to read A, and I'm going to ask you to think, does order matter or does order not matter? So you're reading A and you're thinking, does order matter or does order not matter? So we're thinking, is pepperoni sausage the same as sausage pepperoni? In this situation, yes. So order does not matter. So this is going to be a combination. I have 10 and I'm choosing 7 of them. So this is 10 factorial. I'm going to do the work somewhere else. Ooh. So this is 10 choose 7. You can go ahead and pause your screen and try to simplify 10 choose 7. So go ahead and pause your screen. Simplify 10 choose 7 combination. Okay, we should have at least gotten to this point. So those two things would cancel out. And then from there we get 810 over 6, which gets us our 120. We've had this one before. Take a second and read B, and I want you to just think through to yourself if order matters or it doesn't. So order does not matter again because the first person, like the same, it doesn't matter if it's like Bob, Susan, Jim got it, and then Jim, Bob, Susan got it. So this is another combination. And this will be, there's 52 options or customers, and you're choosing 3 of them. Let's go ahead and pause your screen, try to solve this. Okay, we should end up with something like this. This part simplifies, and if we put that in a calculator, those are some really big numbers. We get 22,100 options. Okay, good job, you guys. This is all for skill 9.